Kia ora koutou. Hello to all. We're all here together today for the same purpose, to talk about insulating new housing and complying with the building code. My name is Devin Glennie and I'm Principal Advisor here at MB. I'm part of the team that looks after the New Zealand Building Code within our Building System Performance branch. Whether you want to design, consent, build, or live in new housing, we're all looking for ways to get better outcomes. Today, we're going to be talking to some experts about the changes we made to insulation requirements in the past year. These changes are practical and easy to do. If you're here for the first time hearing about the changes, we will start with some of the basics on just how to comply with the building code and the resources already available out there to help you with this. If you've heard about the insulation changes before, this webinar is going to be a good recap of what resources we have available. If all goes well, we'll also have a minor announcement here at the end of the webinar, so you can stay tuned for that if you want to hear it live. So some of the presenters we're going to be speaking with today, from MB, we have Richard Allman. He's going to talk about some of the new settings and different compliance pathways for insulation requirements. From BRANZ, we have Ian Cox-Smith and Stephen McNeil to talk about the insulation requirements for roofs and floors and their work on a revised BRANZ house insulation guide and calculation tool. Sam Archer from the New Zealand Green Building Council will talk to about some of the work they've been doing to support the changes to insulation and a tool for the calculation method. We'll be ending the session with some questions to our experts based on feedback we received before today's webinar. And for that panel talk, we'll also be joined by Rob Campion, the technical manager from the Window and Glass Association New Zealand. Just to start us off, we're going to launch a short little poll for everyone. This is just for us to hear about who you are and what you do. And so just tell us a little bit about yourself. All right, so our first batch of resources we're going to talk about are about the building regulatory system itself. So how does the building code work? If you're interested in this topic, MB has already published online learning modules on the building regulatory system. These modules start with the Building Act and outline the regulatory system. They explain different terms about what it means to have a performance-based code, how acceptable solutions and verification methods are used to comply with the mandatory regulations. And they're designed for audiences of all types, including homeowners, and are broken up into 1- and 2-minute little videos. You can find these at learning.building.gov.nz. So if you want to learn more about how the New Zealand Building Code works, this is always a good place to start. We're continuing our work on these education modules, and we'll soon be looking to publish more content on the building code requirements themselves. So this will include a module on H1, which you can learn about how to comply with H1 and insulation requirements, and that should be published later this month. So why are we talking about insulation and why are we talking about it now? Well, our biggest driver for more insulation in housing is to reduce the energy needed to operate buildings. The building and construction sector is responsible for 15% of our country's total emissions. This comes from the production and transport of building materials, the construction process, and the energy used once the home or building is built. We continue to hear strong support that our buildings have to use energy more efficiently if we want to reduce carbon emissions and respond to climate change. More insulation means it takes less energy to heat and cool a building. If a home is easier to heat, it means it can be warmer, drier, and healthier for the people who live there. It will also cost less to run. Insulation is beneficial even in the warmest parts of the country. It is a barrier. It keeps the heat in during the winter and can keep the heat out in the summer. As part of the New Zealand response to climate change, we want to reduce emissions from operating buildings and make sure that our buildings are prepared for the future effects of climate change. Together, we have the power to significantly reduce emissions and slow the rate of climate change while ensuring our homes and buildings are warm, dry, healthy, and resilient to the effects of the changing climate. We still got a long way to go to meet the government emissions reduction plans, but today we'll be talking about simple, practical changes we can do to improve new housing now. The focus of our talk today is about new homes. However, there are other government initiatives that aim to improve existing homes. This is like the Healthy Home Standards for rental homes and the Warmer Kiwi Homes Insulation and Heating Grants program that you can find more information from other government agencies on. So here's our next batch of resources. These are some background on the changes. If you want to read more about why we made these changes to insulation, what feedback we received in public consultation, both in 2021 and 2022, and why we've given the sector more time to get up to speed, you can read all this on building.gov.nz. So those links are building.gov.nz/BCU21 and BCU22. So Building Code Update 21 and Building Code Update 22. On those pages, we publish material on the outcomes of consultation, which contain information and summarize the submissions we receive from the public. These documents here, the one on the right-hand side is the latest outcome document from 2022, which you'll read about the extended transition period and why we provided some more time to get this right and how we are working with the sector to make sure this transition is as smooth as possible. So we're now going to shift to the compliance pathways for insulation, and we're going to hear from Richard Allman. Richard is a senior advisor and registered architect in our building performance team. He's worked in commercial architectural firms and has been with MBIE for the past 3 years. So I'm going to turn it over to you, Richard.
Hi, thank you, Devin. I'll just share my slides. Oh, there we go. Get some slides going. Okay, can you see my slides okay, Devin? I hope so. No doubt someone will tell me if we can't. Yeah, look, sorry. My name's Richard Allman. I work here at MBIE. I'm a senior advisor for building performance, and I've been here about 4 years. As you know, as Devin's already touched on as well, the New Zealand government has committed to be net zero by 2050, and will be addressing climate change. There's various programs that they've started and plans they've started with to get underway with that. We've got the Zero Carbon Act, the Emissions Reduction Plan, National Adaptation Plan, and for the building sector, we also have the Building for Climate Change. And this is a long-term program that not only looks at construction and operation, but future-proofs our buildings from the effects of climate change. And so while the BFCC is developing, we have taken some first steps, if you wish, to kind of prepare the industry and to strengthen the current building code settings. A lot of you will be familiar with this. This is the regulatory triangle. Probably just before we get into this, a bit of history. New Zealand really started insulating maybe in the 1970s, and to be honest, we haven't really kept up with the updates of that. So we find ourselves a little bit behind where we should be. We really need to make some moves pretty quickly. So this image demonstrates or kind of shows us a little bit of the mechanics around the regulatory framework. There's a building code triangle which outlines all the tiers of the building code from the Building Act, well, the building code system from the Building Act down. And what we're focusing on here is in the building code H1.3.1, the provision to provide adequate thermal resistance. Now, when we come across something like this in the code, the adequate thermal resistance, we often find that the definition is found in the acceptable solutions and the verification methods below. So when we have updated the acceptable solutions and the VMs, it's given us a nice, strong, robust pathway, compliance pathway, and that gives us our definition of adequate thermal resistance. So in November last year, many of you will be aware that MBIE published 5 new documents. They're H1 AS1 VM1, H1 AS2 and VM2 and VM3. Today we'll be talking mainly about AS1 and VM1, which cover all housing up and small buildings up to 300 meters squared. Okay, so a little bit about the classifications, the building classifications. when we're talking about all housing, we're talking about detached dwellings, multi-unit dwellings, and group dwellings. So as you can see in this slide here, all of these will use H1AS1 or VM1. And in terms of communal residential, we will be using, well, you'll be using up to 300 square meters, you'll be using H1AS1 and VM1, and over 300 square meters, you'll be using H1AS2, VM2 for the larger buildings. Now, so communal residential might be boarding houses and retirement homes and stuff like that. In terms of communal non-residential, there's no thermal requirements for assembly care. However, assembly services, but assembly care, as you can see, up to 300 square meters, again, you'll be using H1AS1, VM1, and over 300 square meters, you'll be using AS2, VM2. And the last of these, second to last of these different definitions, commercial is obviously not housing. Up to 300 square meters, which is reasonably small for commercial, will be AS1, VM1, and above that will be AS2, VM2. And of course, industrial, there's no requirement for thermal envelope requirements. Okay, so previously, if you've ever used H1AS1 or VM1, you will be familiar with 4218, which contained the technical content in all the versions up to and including version 4. So now in version 5, you'll see that NZS 4218 is no longer cited, and that the technical content has now been incorporated within those solutions. Okay, so our solutions are contained, our compliance pathways are within the acceptable solutions. We've got H1AS1 has the schedule method, which is, as we see here, a tabulated minimum. It's just the tables that you'll all be familiar with. The calculation method, which is a comparison of your building to a theoretical model, and the modelling method. Will be in VM1. Here we see the schedule method. It tends to be easier, but does have certain limits as shown. Glazing, total glazing area must be less than 30%. We have limits on skylights to 1% or 1.5 square meters, and doors, opaque doors, which are counted now, should be less than 6% or 6 meters squared. And the calculation method, you'll notice here the glazing has been reduced from previous versions, from 50% down to 40%. Okay, also ALF. Previously, ALF could be used to calculate your BPI, which was deemed to comply with the adequate thermal resistance. BPI does comply with H1.3.1E, but no longer is deemed to comply with H1.3.1A, which is our clause for adequate thermal resistance, which I showed you earlier. So essentially, using ALF will not deem you compliant for the whole of H1. You can see here we have updated our climate zones. Previously, we had 3 climate zones for the whole country, which was a little bit daft. Really did not reflect the climate very well. For example, Nelson was the same climate zone as Queenstown. Now we have 6 climate zones. These are based off NIWA data and modelling. Generally, these align with local government boundaries as well, which makes it a lot easier to for the councils and for the designers. You'll notice also now that both the AS and the VM have tables in the back where we can find every district, and it's tabulated. So if you're not hot on geography, you can look up where you are, and that will tell you your climate zone. Okay, this is the juicy part, the R values. So these are the values required to be achieved for the schedule method and for the reference buildings when you're using the calculation and modelling methods. We'll start with the roof. The roof is a very cost-effective and simple way to improve your insulation in a typical house. Therefore, the roof value is relatively easy to increase. We've approximately doubled it to 6.6 across the whole country. In terms of fitting the insulation, and as we can see in this slide, it's reasonably simple to add additional insulation in the roof space. However, an allowance has been made where within 500 millimeters of the perimeter, you're allowed to have 3.3, and this is to allow you to fit that insulation in. This really only applies to horizontal ceilings, houses with horizontal ceilings where there are space restrictions. And it's important to note also that this doesn't apply to other types of roofs, such as our roofs, such as skillion roofs. We've also added a comment as well about the requirement to manage moisture in your roof spaces. Various research has shown that the moist air leaking from the house into the colder roof can cause moisture problems in some cases, and so there's a guidance for this, guidance comment for this, and there'll be further information about this coming out. All right, windows. Well, we all know windows are the weak link in the thermal envelope. Typically, they're an order of magnitude lower than wall or than roof R values in the building. And windows and glazing are the most complicated aspect of this update. And a special shout out also to the guys from the glazing and the window industry. Because it really is quite complicated. R values now also apply to doors as well. So the key thing with windows is there will be a staged introduction of changes, starting with November this year, November 2022. We'll be taking the first steps, as you can see here, to R 0.37. Then from May the 1st, 2023 until November the 1st, 2023, we will be taking a second step where climate zone 1 and 2 will remain and climate zones 3 to 6 will move higher. And then from November the 2nd, 2023, we'll be taking a final step for the moment and settling at R 0.46 and R for climate zones 1 to 4. And 0.5 for climate zone 5 and 6. Okay. Just also, there's a note here that other buildings that are other than housing and are less than 300 square meters. They will be stepping in November 2022, as you can see in this table, and November 2023. So really the double step only applies for housing, and that's November this year, May next year, and November next year. Okay, and again here there is a table with generic construction combinations for windows, and these are to allow you to compare different combinations of double and triple glazing, with different frame types. As you can see, we've got aluminium frames, thermally broken aluminium, UPVC and timber. Okay, the floors. The first thing you'll notice here is that the slabs on ground have been separated out from other floors. And that's because suspended timber floors especially are a lot easier to insulate underneath, typically. So you'll see here the new, the minimums for the timber floors are 1.5, and then for that's for slab on ground, and for other floors, the suspended floors start from 2.5 and move upwards to 3. Another important note applies to heated slabs. It's important to note that these are other floor heated floor slabs come under other floors, so you will be using this bottom row of R values, and also these heated floors are minimums for the calculation and the modelling method. So in your when you're using heated floors and using the calculation and modelling method, you can't go below these minimums when you're doing your designs. Okay, previously in version 4, all slabs achieved an R1.3. In this version, version 5, that provision has now been removed. This reflects more refined modelling of slabs. So as part of the extended transition time, this will be the previous R1.3 slabs will be allowed until the 30th of April 2023. So effectively 1st of May, with the new R values will start. But that doesn't mean you can't adopt them earlier. Again, we have a number of tables in the back to help you determine what R value your slab achieves. Obviously, the R values depend on the shape and the size of the concrete slab you are designing, which is considered in this first column here, the area to perimeter ratio. So there's a methodology for calculating your area to perimeter ratio to determine the shape of your slab. Also, another input is the thickness of your or the effective thickness of your walls. Up the top, in the title, we have different R values for the perimeter insulation. Also, if you're doing some finite element modelling, there's a method for doing that in H1BM1 now. It's generally being used quite a lot by suppliers for their own generic systems, and this is quite helpful. And you'll find these tables, extensive tables, in Appendix F. Okay, walls. So the last element is the walls. As you'll see, they do not change much, although some assumptions around framing ratios will be being updated, I believe, with BRANZ. There's no longer any special treatment for high thermal mass and solid timber walls anymore in the schedule and the calculation method. However, if you wish to try and demonstrate that there is an advantage, you can use the modelling method to demonstrate those benefits. So basically, we're moving from R1.9 for the top half of the country to R2, and the colder climate zones stay at R2. Now, there's a number of reasons that this change was limited. A couple of main reasons. First, the sector needs time to adapt with their supply chains. At the moment, there simply is not enough, for example, 140 framing around yet, and these things take time to kind of go through the lead times for it. Secondly, when dealing with composite build-ups of walls, you don't necessarily have to use 140 framing. You could use warm wall construction with the insulation on additional insulation on the outside or surface cavities. There are possible internal moisture risks in some situations. Unfortunately, our building code does not really manage that internal moisture risk well at the moment, but we will be fixing that in the future. So there's a couple of reasons that we haven't been able to advance those, but it doesn't mean you can't use better insulation if you wish. And for a change, all these R values are now contained in one table, so it will be a lot easier to look up and find out what you're actually supposed to be doing. Okay, so just recapping on some of these transition periods for housing. So windows, doors and skylights, the R values start a staged implementation from the 3rd of November 2022. 1st of May 2023, there's another step, and then a final step for the moment in November 2023. The transition time for the walls, floors and roofs has been extended out to May the 1st, 2023. So that's delayed, extended out 6 months. For other buildings, for commercial, communal residential and communal non-residential buildings, childcare transition periods remain unchanged. So version 4 is revoked in November 2nd, 2022, regardless of building size. Okay, just to look at how this kind of works. I know it's all quite complicated at the moment with lots of dates being thrown at you, but hopefully, if we're all visual people, this might seem a little bit easier to understand. We have up the top in the lighter green, directly under the calendar or the dates, we have the acceptable solution H1AS1 4th edition and VM1 4th edition, and they are valid to be used through to November the 3rd, 2022. From then on, they will be revoked and no longer deemed to comply with the building code. There will be an overlap, as you can see on the bottom 2 rows, H1AS1 5th edition and VM1 5th edition, and they'll be amended and issued on in August, and there will be an overlap of some months. Nothing stopping people using them straight away. By November the 3rd, they will be what you're using. If you're using these acceptable solutions, you won't be able to use H1 AS1 version 4 anymore. They'll be amended to retain the existing roof and wall values from the 4th edition through to May the 1st, as we see through here. It's not actually shown on this timeline, and then from then on, we will be adopting the other R values, and this is for housing only. Everything else moves in November the November the 3rd of November, 2nd of November 2022. Great. So I'd really encourage everyone to kind of get familiar with these changes, especially the dates. They're not actually that difficult. once you've read it. So if you go onto our website, you'll be able to find building.govt.nz. Go to building code compliance, H1 energy efficiency. You'll be able to find it reasonably easy, and just make yourself familiar with the changes.
Hey, thanks, Richard. Thanks for outlining those new requirements and those different compliance pathways. I guess it's important for everyone to hear that, like, there's the schedule method, which is the simplest ways that people who want to comply with the building code, but this may not work for every project, and that those other pathways actually exist too. So you have the calculation method, you have the modeling method, and even alternative solutions could be used to demonstrate compliance with the code directly. I think we'll bring back Richard at the end of the session for a few more questions, but at this point, we got our speakers from BRANZ. Today, we're happy to be joined by Ian Cox-Smith and Stephen McNeil. We're going to talk about insulation requirements for roofs and floors. So introducing Ian, in his 27-year career at BRANZ, he's focused on thermal performance of housing, including numerical modeling and measurement of material and system performance. He's currently finishing the last of the analysis needed to update the BRANZ house insulation guide. Stephen, his research interests include ventilation, air tightness, moisture issues, thermal performance, and indoor air quality. He's a regular contributor to the BRANZ Build magazine, and he's been on a number of various working groups and an author of different publications and international journals and attending conferences as well. So I will welcome you both to our webinar, and I'll turn it over to you.
Thanks, Devin. I'll just share my screen. Okay, hopefully that's working. Yeah, so hi everyone, I'm Stephen McNeil. I'm a senior scientist in the building performance team. And Ian, you can probably introduce yourself.
Hi, Ian Cox-Smith. I'm a scientist in the same team as Steve.
So today I'm going to start off talking about a bunch of the resources that BRANZ has got to help with compliance with these building code settings. I'll mainly focus on the roof, and then Ian will talk a little bit later on about walls and floors as we go through. So just try next slide. Okay, so what is BRANZ doing to help at the moment? Well, as Devin sort of said earlier, we've got an update to calculation method tool with the new requirements about to go live. It's just undergoing some final testing at the moment. There's been quite a large update to the house insulation guide, so that's now going to be an electronic tool so we can add more construction types and systems more easily rather than going for a print version. So that includes high performance options, things that allow you to go above code in certain areas. There's been a number of bulletins released recently. There's links at the end of these slides, just with some of the numbers. And something to point out is that all our bulletins are now free, so you can jump on the BRANZ website and download them without having to pay. There's a bit of guidance around slab floors that Ian's produced, and various webinars. There's more in the works at the moment, as well as Build magazine articles. So, like I said, I was going to start with the roof. So the focus of my section of talk will be talking mainly about the schedule and calculation methods. So you can see there the table for the schedule method there on the right. And I'm mainly going to focus on the R6.6 construction value that is needed to be achieved if you're going down this route. So with a pitched roof, it's relatively easy to meet these requirements provided you've got enough slope. It's just some extra insulation, mainly in the central core of the roof. Obviously, you get some clearance issues near the side, so that's why there is the concession has been introduced, which Richard mentioned earlier, where you're allowed to use R3.3 for that 500 millimeters around the perimeter of the roof if you have a clearance issue. However, as you'll see in the next couple of slides, there are some other options that you can do to actually help you retain that R6.6, the full width of the roof. We'd encourage you to do those if you could fit it into your project. And the other thing is that we can do in a pitched roof is sort of a secondary insulation layer on the inside, so a slightly dropped ceiling and a bit more insulation in there. So there's a few different options with varying degrees of buildability. So just a note about the roof concession with that 500mm perimeter. It's only for the schedule method. You can't use it for the other methods. If you do, you have to account for that decreased insulation value. It's something Ian will mention later, but the update to House Insulation Guide does allow you to take that, take account of that reduced insulation value. So if you are putting reduced insulation because you've got a clearance issue and you're using say the calculation method or modeling method, you can account for it. The other thing to note is that it's basically only permissible for roofs with a roof space, and horizontal ceiling. So it basically excludes a skilly roof construction. So I mentioned before there are ways of achieving R6.6 without having to take that concession with 500mm at the edge. One option is a raised heel truss, which is a vertical member from the truss there. You can see in the image, which slightly raises things up. Though you do have to have SED of those vertical connections after talking with the guys' instructions, but it's not insurmountable. And you're right, the other option you could do is an additional insulation layer with a drop ceiling. And that has the added benefit of mitigating a lot of the thermal bridging. So your thermal bridging gets reduced substantially because you've only got those crossing points where you've got two timber members at right angles to each other. So skillion roofs are a bit more of a challenge. You can go quite deep rafters and use higher density products. So, an R2.8 wall product, for example, will fit in 90mm. So you could put 2 layers of that in there. But also that secondary insulation layer. So you can see here on the image, there's another timber member going at right angles underneath with a drop ceiling and additional insulation there. External insulation is a possible route, though the supply chain for all of these things is quite young, and whether it can be supplied in the volume required is up in the air. But it is a possible route that we could start looking into as an industry. Another option that you can do with a skillion roof is to basically go to the calculation method to allow you to use a slightly reduced amount of insulation in your roof and then offsetting that elsewhere in the building. So that means you can raise your insulation levels in your walls, your windows, or your floors slightly. So that's where the House Insulation Guide will really help. Ian's done a lot of hard work to allow you to build some pretty well-performing walls. Other options include, reducing the glazing area or reducing the surface of the building. So, simple things like making the building a little bit more compact, a few less vertical edges, and jutting out pieces of the building can actually have quite an impact on performance. One thing to know about the House Insulation Guide is that the framing ratios that were uncovered with the BRANZ funded Beacon report, looking at what we were actually building in practice, those are reflected in the new House Insulation Guide. So you can get a much better idea of true performance rather than defaulting to something like 14%, which is quite unrealistic compared to what we see on site these days. I mentioned the calculation method tool, so just a little screenshot of it here. It's just going through the peer review process at the moment. So that has the reference building and those things in there. And it's something that I think as an industry, if we're looking to have good outcomes, we need to start moving more towards modelling and simulation methods. And so the Building Climate Change Program has sent a very clear message around that. So things like the calculation method tool are a bit of a stopgap before you start to move into more holistic modelling of the building to see its true achieved performance. And it's at that point that you can really get a handle on what you're delivering for your clients. One thing I'd just like to reiterate what Richard said before about the air barrier at the ceiling diaphragm. This is actually a really important thing to note. We've seen multiple buildings where there has been moisture issues in the roof space. Typically, it's been penetration through downlights or disconnected ventilation ducts, all these kinds of things, shifting large quantities of moist air up into the roof space and condensing on the roof deck. So I would suggest to try and make that ceiling diaphragm as airtight as you can. Simple things can really help there. There's the newer LED downlights these days are a lot better sealed than the previous open ones that we had. But it's just being wary that we are halving the energy flow across that ceiling now. So that that the energy flow is actually quite important to dry the assembly out. So we just need to be wary. And a decent air barrier is more important at this stage than controlling vapor diffusion. It swamps it by quite some way. You've got another option, and that's hybrid roof construction, which is effectively a rigid insulation on the outside of a construction with some loose fill back in the framing voids. However, the international evidence of these kinds of systems suggests there is a bit of a risk there in terms of moisture accumulation. So we need to just treat a little bit carefully and make sure that the right guidance is there and the right controls are in the system to mitigate any risk. So, and that's a topic of current research here at the moment. So I'll hand over to Ian now, and he's going to talk a little bit about the house insulation guide update and a few other things.
Thanks, Steve. Well, as Steve says, the house insulation guide looks completely different now. It's not a publication. It's a spreadsheet based. So a workbook with 5 spreadsheets, 2 for roofs. That's roof space, type roof, skillion roof, slab floors, suspended timber floors, and walls. Unlike the previous house insulation guide, which was based on the one-dimensional R-value calculations tool from NZS 4214, the whole house insulation guide is now done using 3D finite element modelling. It was always done that way for the floor slabs, but now, to be consistent and following international best practice, the walls and ceilings are also done using 3D finite element modelling. The advantage of doing it this way is that it's much easier to incorporate the top and bottom plates, for instance, into the walls, which is a requirement now with H1. So that's a 3D model to do that. And takes better, as Steve said, takes better account of the higher framing ratios that was found from the Beacon report. So if we move on to the roofs examples that Steve was talking about, and there, so on the left is a skillion roof with a secondary insulation layer. Now we also have the option with these of changing or adding things that weren't in the house insulation guide, such as changing the conductivity of the material, because not only does it depend on the R value of the insulation, but the effectiveness depends on its thickness as well, so its conductivity. And to achieve higher R values from a skillion roof, take advantage of the higher density fibrous products that have been developed. So the two examples that are in the spreadsheet for the secondary insulation layer R1 overall or R1.2 overall, and that's achieved through 50 millimetre deep horizontal battening, which and then insulation, either high density polyester or a high density glass wool. So polyester in the case of a R1 and high density glass wool in the case of 1.2. So it's just a case of adding a bit more framing and adding a bit more insulation. But the advantage is that the framing is not in line with the primary framing, so its effectiveness is much higher. On the right's example with the pitched roof, the ceiling space, and again, there's the ability to alter the conductivity of the insulation material, but also the demonstrates on the right column is when the insulation is just simply fitted between the rafters or cords, and on the left is when the insulation is fitted in a way where it covers over the top of the framing. And that can be done either by cutting the insulation so that it spills over the top. It's easier now with thicker insulation, or alternatively installing 2 layers. So there still needs to be methods developed for installing these products, but the industry's come up with R7 and R8 insulation products, or alternatively, most of the insulation suppliers now have tables for correcting when you stack one layer of insulation directly on top of another one, compresses the insulation underneath slightly, and there's corrections for that when necessary. So, as Steve said, for the walls, ability to adjust for higher framing ratios. So now there isn't the default values of nominal stud spacing, because that's no longer relevant. So now we need to understand what the real framing ratios are in the walls. Of course, H1 allows to exclude some of the framing associated with windows, but not all of the extra framing that you get in the wall, such as where internal walls, junctions, etc. So, as with the ceilings, the addition of secondary insulation layer on the internal makes a substantial difference to overall performance. There's an example there of that was a basic wall with additional insulation. With this floor example, again, there's lots of options for floors, because including either going for lower conductivity insulation, or alternatively deeper joist height. And the tool gives a bit more interpolation, finer detail in terms of the joist spacing can be adjusted accordingly. For the slab, for example, this one spreadsheet incorporates all of the tables that are in H1, but plus there's additional data. It's interpolated into a finer degree with the area to perimeter ratio, and the overall R values now can be reported to second decimal place, and the addition of topper insulation on top of the slab, which is particularly effective. And in the case of small slabs, ones with area perimeter ratios of 1.6, for instance, it's with topper insulation of R1, it's possible to achieve compliance even for heated floors, or alternatively the values for Lower South Island. So, as well as those tools, of course, there's big build articles, some and upcoming webinars on specific topics, such as the calculation methods and compliance pathways, and using some of these tools. And there's some of the bulletins that are out there, and they're free on our website. We cover a lot of these topics.
Hey, thanks, guys. Thanks for showing off all those resources. It looks like there's a lot of out there, and that the BRANZ house insulation guide being more interactive, that looks like it's going to be really useful for people. Get a lot of that details and how they actually can comply. So we're going to move to our last speaker here to present, and that is Sam Archer from the New Zealand Green Building Council. So Sam is the Director of Market Transformation at NZGBC. He has 20 years experience in the construction industry as a sustainability consultant and mechanical engineer. So he's responsible for running the sustainability energy assessment tools such as Green Star, HomeStar, HomeFit, and Neighbors. And he's going to talk about some of the work they've been doing at the NZGBC and how they're supporting the H1 update. So thank you, Sam.
Wonderful. Thanks so much. Yep, I'm just sharing my screen. Okay, just making sure that everyone can see that. It's all good, Devin. Can everyone see that?
Yeah, we can see everything.
Wonderful. Yeah, very good afternoon to everyone. And yeah, looking forward to hearing the questions afterwards. Okay, so what I'm going to be talking about today is really some of the work we've been doing to assist this new building code update, particularly around the calculation method, which is really the second method after the schedule method in acceptable solutions, AS1 for the new H1. So the reason I've got this page on here is this is a snippet from the AS1, which has an awful lot of very sort of complicated calculations and equations for doing the calculation method. But in fact, it's really quite a simple calculation. Really what you're doing with the calculation method is comparing the heat losses from your actual building, your proposed development that you're working on, and comparing those heat losses to a reference building which has basically the schedule, the standard default R values from the building code. Some important things about what the reference building is. So it's the same size and shape as your proposed building, except with a few things changed. So the main things that are changed are the R values are as per the schedule that's in force at any point in time. I'm sure as you've been talking about through the previous talks, the R values, of course, are being phased in over time. So this is showing the R values from the end of next year when the full new H1 update has come into force. So the reference building would have these R values as standard. If you've got skylights in your actual proposed building, then the reference building calculation method reference building has no skylights, so it will fill in those skylights as normal roof area. And then finally, the big one is that the window area is fixed at 30% of the wall area. So each of the walls in your house would be assumed to have 30% glazed area, so different from the actual glazing area in your house. And I guess that offers a real opportunity for designers, because if you're working on a home that has smaller window areas, 30% is actually quite a large area of windows in most typical houses in New Zealand. So if you've got less area of window than that, then that really helps you to improve your performance under H1. Okay, some important caveats here, which is that this calculation method can only be used if the window area is less than 40% of the wall area. So if you've got a highly glazed house like this one in the picture, then you cannot use the calculation method. You would have to, and indeed you can't use the schedule method either. You would need to be doing full thermal modeling of your house, which I'll talk about at the end. Okay, so the calculation method is pretty simple. So I'm going to show you sort of a more sophisticated version on some later slides, but really this is just to point out that anyone with reasonable Excel skills could do the calculation method on a simple Excel sheet. So this one here shows walls, roofs, slab and windows, and shows the proposed area of those and their R values and the heat loss from those. And then similarly, you've got the reference building heat losses and so on. And really, as I was going through earlier on, I'll just jump back a couple of slides. We're comparing this heat loss the proposed building to the heat loss of the reference building. And so, you can do that fairly simply in an Excel calculation. However, NZGBC has provided on its website a very simple a calculator that does all those calculations for you. So if you navigate to this nzgbc.h1calculator.org.nz, you can find this very simple calculator here for doing it. And indeed, if you just Google NZGBC H1 calculator, you'll find this page fairly easily. And again, what this is doing is you've got a proposed building here on the left. So this is where you're going to input your different elements here: wall, roof, slab, and so on. The area of those elements and their R values. It will work out the heat loss of those, and then automatically work out the reference building here and compare the two and tell you whether you're compliant under the building code version in question. Okay, so when might this calculation method be useful? Well, in particular, it'll be where you might struggle with your particular construction types to meet the R values that are in the schedule method. So a building type that's often brought up as being difficult to meet the new R6.6 requirements would be skillion roofs. Very typically, they don't have enough void in them to get enough insulation to meet that R6.6 value. So, I mean, there are alternatives to that. So, you could build up a skillion roof as a warm roof, where you've got the insulation above the sort of structure of the roof here. So that's one alternative. But, let's say you didn't want to do that. Just to give a project example here. So here we've got a duplex a house here. So we've got two houses side by side, and clearly, you've got a sloping skillion roof in there. You might argue, well, it's difficult to meet R6.6 in that case. So what can you do? So these are the values that are required from 1st of May next year. Obviously, we've got that final 0.46 R value required for Windows in November 2023. But let's just assume from the 1st of May, we're required to meet these values here. So these are the values that are going to be input into the calculator for the reference building. So just taking our concrete slab here, we've got an overall concrete slab area of 85.9 square meters, a perimeter of 40.8 square meters, giving you an area to perimeter ratio of 2.1. So, you can look up the R value of your slab, of your actual slab, from the tables in AS1, or alternatively, of course, great presentation from BRANZ earlier on. There are other tools available for calculating those. So here we go. This is a sort of fairly simple kind of example of the calculation method here. We've got R1.3 going in for our actual house, for our proposed house and its area. So the heat loss is 85.9 divided by 1.3, which gives you the heat loss here of 66.1 watts per Kelvin. And then our tool will automatically input the R value of the reference building here, R1.5, and you can see here the heat loss is less because you've got a better R value in the reference building. Okay, and then we look at the window areas. So the window area is 44 square meters. The gross wall area is 198 square meters, giving you a net wall area of 154.6. And you can see here that the window percentage is quite low. It's only 22% of the walls are glazed in this case. So if we move on here, we can see actually the window area is higher in the reference building because the window to wall ratio is 30% as a default in the reference building. So you can see here that although we've got worse heat losses from the slab, we've got much better heat losses from the windows as a result of that. Okay. Then finally, we put the slab area and the roof area in here, which gives us our completed table. And you can see here that the total heat loss is less in the proposed building than the actual building, so we're compliant. And you can see here, although we've got R6.6 as the requirement for the schedule method, we've got away with R2.9 in here mainly because we've got a reduced window area for our proposed building. Okay, just to finish off, so as I said, larger glazing areas would require the modelling method. The modelling method requires you to use modelling software that looks at the annual heating demand rather than the peak heating demand. NZGBC has its own tools available. Please get in contact with us for doing that. But there are other tools available, I should say. And so that's the final third method that you could use for compliance with building code if you've got big glazed areas. Okay, that's me done.
Thanks for that, Sam. It's good to hear about that calculator tool and the other work you're doing with the modeling methods and things like that. So just to reiterate, if you had more questions on that, you can always contact the NZGBC and get some more information. So it's now time for some of our panel talk. So I'll get everybody else to join in here on video. And so we have a few questions that we've heard from people about these, about the changes and what's required. So we're just going to go through some of them. So the first question is for you, Richard. Just can you recap how those transition periods work again? Just what are those important dates that people need to remember?
Yeah, okay, Devin. So the new changes are published with a transition period, which is essentially an overlap, and that allows you to use the previous documents for a certain amount of time. The new documents and the new requirements can also be used already to show compliance. So essentially, they're as we saw in that diagram, they're overlapping. However, at the end of the transition time, the old documents are revoked and can no longer be used. And in this case, that will be November the 3rd, 2022. Sorry, that November the 2nd, 2022. So after this date, the 4th edition H1 acceptable solution and verification method no longer. Okay. The new additions for H1AS1 and H1BM1 documents, they also have specific dates kind of folded into them, with the double stepping of the windows as well. So recapping from May the 1st, 2023, new building work in homes must meet the new wall, floor, and roof insulation performance requirements. Up until that date, there's an option in the 5th edition document to use walls, roof, and floor R values that are equivalent to the previous requirements of version 4. It sounds very complicated, but once you see it, it's actually quite simple. Windows and door installation requirements will continue to see a staged implementation process. So starting from November 2022, May, and then November 2023. For the windows, so the construction in the Upper North Island climate zone 1 and 2 will keep the previous timelines, with windows and doors requiring an interim minimum R value of about 3.7. By the 3rd of November 2022, the requiring a minimum R value of 0.46, sorry, a lot of numbers, by the 2nd of November 2023. Construction in the rest of the country, climate zones 3 to 6, will now also have an interim increase. So these zones will be required to reach a minimum R value of 0.37 for windows and doors by the 3rd of November 2022, and increase to 0.46 zones 3 to 4 and 0.5 zones 5 to 6, 6 months after that on the 1st of May 2023.
Yeah, and there are a lot of numbers, but they are in that outcomes document. They're summarized there with that graphic you showed earlier. So that again, that document's located on building.gov.nz/BCU22. You can also see them in the AS1 or VM1 documents themselves. They're shown in tables as well. So we've heard a lot about what people's resources are and what education's going on about the changes. Maybe we'll just recap some of those. So Richard, where can people go to find information about some of the insulation requirements for the building code?
So we can obviously go to building.gov.nz and also visit the Code Hub website. and there will be an H1 education module, which will be getting published later this month.
Yeah, and that Code Hub website also includes BRANZ appraisals and code mark products. On there. You can search for any insulation products and it will bring those up. Maybe Ian and Steve, can you talk about some of the resources BRANZ has and where they can go online?
The house insulation guide will be one of the really useful ones. As you saw from what Ian had, you'd be able to build up an assembly quite easily to see what you're able to be achieved. You've also got the series of bulletins and all the other things that we've got out there to really help people go beyond the status quo.
When do you expect the house insulation guide to be online?
Ian?
Just sorting out the diagrams, getting them all coordinated, because there's hundreds of diagrams to coordinate with the selection boxes so that the right picture's brought up. But we wanted to finish it this week, but it might be pushing into next week.
Yes.
We'll be releasing it to the insulation manufacturers without the pictures sorted tomorrow.
Yeah, so it sounds like it'll be available shortly.
Yep.
Sam, do you want to talk about some of those resources that you have available and what's online?
Yeah, sure. So there's just the calculator that I was talking about earlier on. If you just Google NZGBC H1 calculator, you can find that calculator, which is useful. And we have been running a series of webinars, and I'm sure we have some others planned. So if you go onto our on our webinars page on the NZGBC website, you can see what webinars we've got planned coming up for the H1 changes.
All right, thanks everyone. Rob, I got a couple questions for you about windows. So the new requirements mean that we need higher thermally performing windows. We heard in some of our consultation, there was uncertainty about products and if they'd be available to meet the demand. So what have the window and glass suppliers actually said about the availability of products?
Devin, to be fair, a lot of the concerns were out there were a little erroneous, but that's not to say a significant amount of pain and resource haven't gone into trying to achieve, the desired outcomes. In terms of frames, certainly some of our suppliers were grateful for a little bit more time to implement the changes, yet others were disappointed because they had programs set in place, around the existing targets. Glass, it's all on its way. And that's part of the reason that we had proposed this additional step in the implementation. All of the glass is imported into New Zealand. That space had been booked, was on ships, and was, like I say, it was on its way here now. So, the industry, we're ready to go.
Yeah, and we put some of that details in their outcomes document as well, basically to say that we heard that pretty loud and clearly that this was something that the window and glass industry was looking to do and looking to implement. So another question about windows. How exactly do you determine the thermal performance of a window on site? What can builders show to BCAs to make sure that they're installing a window that meets the R values? And kind of what area work are you guys doing in this area?
Okay, Devin, we're currently engaging with councils on this very subject as we speak, just trying to understand what it is, what information it is that they require and how we can best help them. It's actually just a fraction too early to say exactly what we're going to be doing there. A number of things have been talked about, whether it's reference to E111, labels, or product performance statements. So yeah, unfortunately, I don't have an answer for you today, but we are engaged with councils and trying to make it as easy as we possibly can for everybody.
Yeah, so you're actively working on this, and this is something that's quite squarely on your radar.
Oh, absolutely.
So we're talking about some of these more specific construction details. Question here, Ian, for you. Just can you put insulation under the footing of a floor slab? What is the best place to where's the best place to put the insulation in a slab?
Well, the question about putting insulation under the footing, or in fact wall thickenings and any other structural parts of the floor slab, is a question that was put to the 3604 working groups. And the conclusion was that it requires specific engineering design. It's outside the scope of 3604 3604, unfortunately. So at this stage, insulation, we only got solutions for insulation under the slab itself, not under the footings part of it. And like I said, not under wall thickenings and things like that. But the good thing is that if insulation, the other options are still to put insulation under the slab on the perimeter or on as a topping insulation.
Right, thanks. So there's a few options there, and that's stuff that's covered within that house insulation guide as well. Have you looked at options in there on looking at different types of insulation? Are you using combinations of rigid board and fibrous products?
Steve, a question for Steve, really.
Yeah. Yeah, thanks, Evan. We have, but there are certain risks involved when you get a change in diffusion resistance and thermal conductivity. There's a condensation plane risk that needs to be mitigated. So there's just a little bit of, probably specific design and a bit of care and attention to make sure that you're not creating an undue risk is quite important if you start going down that track. Whereas if you're building a assembly out of multiple layers of insulation, if you keep the products very similar, then you don't raise that risk profile.
Yeah, so about those risks, are there other things particularly you think the industry should be looking out for?
Just reiterating the maintaining the quality of the air barrier at the ceiling, really. That's fun to watch. And shaded sites in particular, roof-based moisture could prove to be a bit of a problem if you don't maintain a decent air barrier at the ceiling. So that means if you've got conventional plasterboard, then you're square stopping or doing a bonded cove or cornice. So there's not really much potential to leak around the edges. Using sealed downlights or no downlights, using other lighting options. Yeah.
All right, thanks. So we've been talking today about kind of building to the code minimums, but we can also talk about some of the work we do to build above the code minimums. Let's talk about some of those resources out there. Stephen, what does BRANZ do to encourage building above the minimums?
So there's a bunch of those bulletins that have come out recently on high performance wall, floor, and roof details, and the HBCD handbook as well. So there's quite a few good resources there now to help people really step above what they're currently doing. One thing to watch, obviously, is once you start going down that route, you need to be quite careful about how you model your building. Solar gains can be quite a problem for heating, so just make sure that you are mitigating your risk and you're doing a thorough job of good design or efficient design.
Another point to note is that the previous house insulation guide was aimed at building code compliance, so the 1D calculation is a building compliance R value, whereas the 3D modelling gives a design R value, and so that's very much aimed at calculation method and beyond. So what designing with more accurate R values.
And Sam, do you want to talk about some of the resources you have for building above the minimums?
Yeah, sure, Devin, it's a great question. I mean, I guess our primary one is through our Homestar program, which is looking at sort of holistic methods for improving the sustainability performance of homes. I think the really crucial point to get across is that MBIE's own Building for Climate Change program is looking to move from just looking at R values to looking at overall performance in terms of annual energy use or annual heating demand of the house in kilowatt hours rather than kilowatts. That's what Homestar does. We very much advocate for actually doing modeling of homes because, as Steve said, just doing better R values can actually result in perverse outcomes like overheating. So doing a full annual energy model of a house, we think is where the industry needs to move to, and indeed what Homestar is requiring, and we have the tools now, the modeling tools, in order to allow people to do that. So that's our real recommendation, is for the industry to move to annual energy modeling rather than just look at R values.
Yeah, so what we've been talking about today is how people comply, but we know that more change is coming in the future, that there's other things that we'll be looking at in the future, and that there's already resources out there to start prepping people and getting them prepared for looking at more holistic modeling and holistic performance. Okay, I think we're going to wrap up some of these questions here. Richard, we have one last question here, and it's time for our kind of minor announcement. We talked about the new AS and VMs that need to be revised for the transition periods. There was also some typos we had picked up that needed to be corrected. When will those documents be available?
Well, the documents, if I'm not much mistaken, should be available now. Is that correct, Devon?
Yes, so
Okay.
they are online now. So while we've been chatting in this webinar, all the documents have been uploaded. So there's now a H1AS1 5th edition Amendment 1, VM1 5th edition Amendment 1, AS2 1st edition Amendment 1, and VM2 Amendment 1 as well. So those documents are now posted. They're effective today. So like I said, they have been corrected with some minor typos we picked up in the last 6 months, but they also include the new requirements for the extended transition period. So those are all available for you to download and have a look after this webinar. I want to thank everyone for presenting and answering questions with us today. This webinar will be recorded and posted online for future use. You can also look at our website for more information or other resources on Code Hub. The last thing we'll do here is just a survey for people to attend. And if you just want to answer the survey as it comes up on your screen of looking at what feedback you would like to see in the future and what other topics you might want to hear about. So thank you, everyone. And I'll end today's webinar a little bit early.